Time for some more integration by parts. And we will need to see some slightly more exciting examples. This one, e to the x sine x, is a classic. Whenever you see e to the x and trig together, you think integration by parts, because for one thing, u substitution doesn't give us anything here. We can't find the inside function and then the derivative of that multiplied on the outside. No, it looks like two functions multiplied together. So we have u equal e to the x, dv equals sine x dx, and that's the best idea to try because e to the x is its own derivative, so at least it doesn't get more complicated. And then the antiderivative of sine is negative cosine. You need that minus on there. So by the rules that we know, the antiderivative of the original is u times v, so negative, and then e to the x cosine x, minus the integral of v du. So that'll be the negative cosine x times e to the x dx. Of course, that double minus, the minus can come outside and make it a plus. So we have plus cosine x e to the x dx. Alright, so in this problem, it looks like we haven't really gotten any farther yet because we still have an integral with the e to the x and a cosine x. So, yep, it's time to do another integration by parts. This time we stick with the same strategy. Let u equal e to the x and dv equals cosine x dx. This time the antiderivative of cosine is sine x, and the derivative of e to the x is itself again. So when we put them back into the problem, now we have to be careful not to forget to copy from above. We still have that negative e to the x cosine x from the first integration by parts. Now the second integration by parts is e to the x sine x uv minus the integral of v du, sine x and e to the x. So I just write it e to the x sine x for clarity. Alright, again, looks like we haven't really gotten anywhere. Instead, what we ended up with is the same problem that we started with, e to the x sine x dx. Now it happens to have a minus out front. So let's look and see what we have here. What we have here altogether is that the integral of e to the x sine x dx equals the two integration by parts pieces, a uv and a uv, and then minus e to the x sine x dx. But we've solved it, because what we can do is add e to the integral of e to the x sine x dx to both sides. That'll get rid of that negative 1 on the left, and I'll go ahead and show it, plus integral of e to the x sine x dx. We don't know what it is yet, but we can add it to both sides. It's something. And so we get 2 times e to the x sine x dx on the left equals negative e to the x cosine x plus e to the x sine x. And then we just divide both sides by 2, or multiply by 1/2. And so now we see e to the x sine x dx, and then a negative 1/2, that minus sign came from above, plus 1/2 e to the x sine x, and plus c, because that's our answer. So you can do integration by parts twice. You can see it up above there. And what you end up with is your original equal to something minus the original. But then when you add the original to both sides, the integral to both sides, and in the book they often decide to call that I, just to simplify it, but you can see it as just adding the integral to both sides. And then you'll have 2 of them on the left of that equal sign, so you can divide by 2 and get the final answer. And then of course you can check your work. Just take the derivative of that negative 1/2 e to the x cosine x plus 1/2 e to the x sine x. And sure enough, you get back e to the x sine x, what's inside of the integral.